In 1969, a machine stood up in Ohio. Not rolled, not crawled, not drove. It stood up. 2 steel walking shoes lifted a machine the size of a 22-story building and set it down again, slowly, deliberately, like the earth itself had decided to move. Its bucket could tear away 220 cubic yards at a time. Its body weighed roughly 13,500 short tons. When it crossed a coal field, it did not look like equipment. It looked like industrial civilization stepping out into the open and revealing what it really believed about the world. Its name was Big Muskie. And the easy version of this story is that Big Muskie was the largest dragline ever built. That is true. It is also incomplete. Because Big Muskie did not come from a military giant, or a Silicon Valley fantasy, or a government moonshot. It came from a factory in South Milwaukee, Wisconsin. A lakefront industrial town of roughly 20,000 people. A place built around a company that started with an abandoned foundry, a banker who could read patterns, and a master mechanic who could turn those patterns into steel. That company survived the collapse of one century and the rise of another. It helped dig the Panama Canal. It built machines for 2 world wars. It created some of the largest self-propelled machines ever to move on land. It overexpanded, broke, restructured, consolidated an industry, got absorbed by a larger empire, and then watched its own factory fall silent in 2016 after 123 years of production. This is the story of Bucyrus-Erie. Not just the company that built Big Muskie. The company that taught America how to move the ground beneath its own feet. If you want more long-form stories about the factories, brands, and machines that built the modern world, subscribe to Rust and Glory. The story begins in the 1880s, when the United States was not yet a settled industrial power so much as a country under violent construction. Railroad mileage exploded in the decades after the Civil War. New lines pushed westward, southward, and through places that, on a map, looked abstract until somebody had to cut through rock, grade a bed, lay track, and hold the whole thing stable enough to carry freight at speed. Every mile of railway represented an engineering problem, but it also represented an excavation problem, and excavation at continental scale was still primitive. There were patents. There were ideas. There were a few builders. There was not yet a mature industry capable of meeting what the country was asking of it. That was the opportunity Daniel P. Eales saw. Eales was not a classic inventor-founder. He was a banker, an organizer, a man whose real gift was reading where future demand would outstrip present supply. He moved through rail and coal circles in Ohio, watched the way capital flowed, and learned something more valuable than mechanics, where the bottlenecks were. He understood that the United States was going to need far more digging power than its small collection of foundries and machine shops could provide. He also understood that whoever could build reliable excavating machinery at scale would not simply sell equipment. They would attach themselves to the physical creation of the country. In December 1880, Eales and his associates acquired the abandoned Bucyrus Machine Company in Bucyrus, Ohio for $17,000. Even now that figure sounds modest. At the time it was still a gamble, but not a reckless one. The foundry existed. The rail connections existed. The industrial demand existed. What did not yet exist was the right product and the right technical leadership. So Eales made the first great decision of the company's history. He hired John Thompson. If Eales was the pattern reader, Thompson was the mechanic. He knew machines from the inside out. He understood how metal behaved, how systems failed, how production translated drawing into object. The division between them was clear and unusually disciplined. Eales controlled capital, markets, and direction. Thompson controlled the technical core. Neither pretended to be the other. That mattered because many industrial companies destroy themselves by blurring genius and authority. Bucyrus began by separating them. At first, the company made ordinary railroad hardware. Wheels, switches, cylinders, handcars, solid work that paid bills but created no durable edge. Eels watched those years carefully and recognized the danger. Standard parts can keep a shop alive, but they also make it replaceable. Another shop can always learn to do the same thing. Another foundry can always bid slightly lower. A business like that survives on habit until the market decides habit is not enough. The opening came with a railroad order for a steam shovel. Not a giant contract. Not a cinematic turning point in real time. Just the kind of order that only becomes historic in hindsight. Steam shovels already existed, but the existing designs still carried serious limitations. They were useful and clumsy at once. Thompson saw where they wasted motion. Eels saw what that wasted motion meant commercially. Thompson redesigned the machine around rotation and versatility. Instead of forcing the entire machine to reposition every time the digging direction changed, the upper structure could swing around its axis. Instead of serving one narrow role, the machine could function as both shovel and derrick. What looked like mechanical refinement was actually an economic weapon. Less dead time, broader utility, more work per crew, more value per machine. Eels understood immediately what this meant. He cut away the distractions. Standard railroad products were no longer the center of the business. The company would go deep, not broad. Shovels, cranes, dredges. Nothing else deserved the same attention. That kind of aggressive specialization often looks reckless while it is happening. It narrows revenue, increases dependence, and frightens cautious people. But it also compounds learning. Every machine teaches the next one. Every problem solved becomes a barrier for competitors. Every field repair becomes engineering memory. A company that keeps dividing its attention can stay busy. A company that concentrates it can become irreplaceable. In 1883, Thompson's consolidated steam shovel and derrick won first prize at the National Exposition of Railway Appliances in Chicago. The importance of that moment was not the medal itself. It was that a relatively small Ohio firm had publicly demonstrated that it was building excavating equipment of national significance. Orders began to move beyond local networks. The company's name crossed state lines. Reputation, once established in heavy industry, tends to travel farther than advertising ever can. By the late 1880s, Bucyrus had extended into dredges as well. That move opened harbors, canals, riverwork, and a whole new class of infrastructure contracts. The machines were different in application, but the core advantage was the same. The company was developing deep, repeatable expertise in moving enormous quantities of material under difficult conditions. That, in the end, was the real founding product. Not a single shovel. Not a single patent. A business model built around hard-to-copy competence. Eels had found the thing he was looking for when he bought an abandoned foundry. A moat made not of money, but of accumulated know-how. Success created the next crisis. The original Bucyrus Works in Ohio proved the company could build a market. It could not support the scale that market was demanding. The site was too constrained. Expansion land was limited. Transport options were inadequate for the size of the machines the company was beginning to imagine. Heavy industrial success has a physical requirement that modern business often forgets. You cannot scale large machinery abstractly. The building, the yard, the rail access, the dock, the craneage, the raw material flow, the assembly space, these are not background conditions. They are the business. In 1891, South Milwaukee offered Bucyrus a future in one package: cash, land, dock access, rail access, worker housing opportunities. A city willing to move Chicago road itself to make the site workable. That last detail tells you almost everything. Municipalities do not reroute roads for ordinary tenants. They do it when they believe a factory is going to become the anchor of their future. Eels saw what South Milwaukee offered that Bucyrus, Ohio could not: access to both inland America and the wider world. Railroads carried heavy machinery into the continent. Lake Michigan linked the company to the Great Lakes and onward routes beyond them. Bucyrus was no longer just building industrial tools. It was building objects so large that geography itself had become part of the manufacturing equation. The move was formalized in 1891. The new South Milwaukee operation opened in 1893. More than a relocation, it was a transformation. In Wisconsin, the company began to assume the form that would define it for more than a century: a self-contained heavy manufacturing complex tied intimately to a town that would grow around it. The workers who filled the plant in its early decades were largely immigrants and the children of immigrants: Polish, German, Armenian, Bohemian, and others who brought with them not only labor but working traditions, mechanical habits, and foundry discipline. Industrial America is often narrated through products and executives, but factories are really memory systems carried in bodies. Somebody teaches somebody how to set a tolerance, pour a casting, listen for trouble in a drive, judge a weld bead, balance speed against failure. That sort of knowledge rarely appears in annual reports. It is why some factories can survive shocks others cannot. Bucyrus understood early that labor stability was not a soft issue. It was a structural one. Between the 1910s and 1920s, the company did something unusual and profoundly strategic. It invested in the surrounding environment of work: homes, utilities, community infrastructure, the Bucyrus Club, and the broader civic fabric that helped bind workers to place. This was not philanthropy in the sentimental sense. It was industrial statecraft at town scale. A worker who owns a house near the plant, whose children grow up in the local schools, whose neighbors also work at the same factory, is less likely to disappear the first time another employer offers a marginal wage premium. What Bucyrus built in South Milwaukee was not merely a labor force. It built continuity. By the early 20th century, the plant had become an integrated industrial organism. Foundry, forging, fabrication, machining, assembly, shipping, as much as possible brought under one system, one roof, one culture. That mattered because the machines were increasing in size, complexity, and consequence. Customers did not want a glamorous promise. They wanted equipment that worked in mud, water, frozen overburden, tropical heat, remote mines, and places where failure meant ruinous delay. Factories earn myth when they consistently do that kind of work. The effect on South Milwaukee was total. Bucyrus became the city's dominant industrial fact. Generations moved through its gates. Street names, housing, local businesses, clubs, and civic identity all bent around the plant. This is the part of industrial history that often gets flattened into statistics. Payroll numbers matter. Output numbers matter. But what a great factory really does is organize time. Shifts determine traffic. Paydays determine downtown business. Hiring waves determine school enrollments. Retirements shape neighborhood age. The building becomes a clock and a center of gravity. When people later said South Milwaukee did not simply lose jobs when the plant went silent, they were saying something precise. They were saying the city lost the institution around which ordinary life had been arranged for over a century. That sort of dependence is dangerous. It is also exactly what made the place powerful. Because once the town and the factory were bound together, Bucyrus could accumulate something even more valuable than contracts: intergenerational skill. Sons followed fathers. Sometimes daughters followed mothers. The work culture thickened. The company became better because the town kept feeding it people who had already spent years hearing about the machines at dinner tables and seeing what factory discipline looked like from childhood. Modern management language would call this a talent pipeline. South Milwaukee called it life. There are contracts that pay well, and there are contracts that permanently alter how the world perceives you. For Bucyrus, that contract was Panama. The French failure in the 1880s had already given the canal mythic status before the United States even took over. Disease, landslides, corruption, mud, heat, and engineering overconfidence had turned the project into one of the great modern cautionary tales. When the United States assumed control in 1904, the canal became more than an infrastructure project. It became a national demonstration of competence. The task was straightforward on paper and brutal in practice. Cut through unstable tropical terrain, remove staggering quantities of material, control disease, and prove that American industry could finish what European ambition had not. What the canal needed was not just manpower. It needed dependable digging power on a scale large enough to convert ambition into measurable excavation. Bucyrus became central to that effort. The figures are still striking more than a century later. Bucyrus supplied 77 of the 102 steam shovels used on the Panama Canal. That meant roughly 3/4 of the mechanical excavation power on the most important construction project in the world came from one factory in South Milwaukee. When you combine heritage lines later absorbed into the company, the institutional footprint is even larger. But even using the cleanest conservative number, the dominance is obvious. These were not ornamental machines. They were 95-ton working beasts with 5 cubic yard buckets, mounted on temporary rails and operated in conditions that punished both metal and muscle. Crews labored through tropical heat and mud, moving track as the machines advanced, feeding boilers with coal, maintaining operation amid a landscape that collapsed without warning. Landslides at Culebra Cut could bury equipment and erase days of progress overnight. Every ton removed had to be wrestled out of a living geology that refused to stay where it had been cut. This is why Panama mattered so much to Bucyrus's reputation. The canal was not a clean technical demonstration. It was a chaos test. A machine that performs under controlled conditions proves good engineering. A machine that performs in Panama proves something closer to legitimacy. The output numbers tell that story with more force than rhetoric can. In March 1910, a Bucyrus shovel at Culebra Cut excavated around 70,000 cubic yards in 26 days, a project record. Across the life of the canal job, individual Bucyrus machines averaged over 1 million cubic yards moved. These were extraordinary performances not because they were achieved in calm conditions, but because they were achieved in one of the worst work environments on Earth. Then Roosevelt climbed into one. In November 1906, Theodore Roosevelt visited Panama and sat at the controls of a Bucyrus shovel. The photograph of the president on that machine became one of the iconic images of the canal era. It worked as politics, theater, and advertising all at once. Bucyrus did not need a slogan after that. If the President of the United States wanted to be seen inside your machine while inspecting the greatest construction project of the age, your brand had already crossed into symbolic territory. Panama did not make Bucyrus technically capable. It proved that capability at the highest level available. And once that proof entered the world, the company's market position changed. It no longer had to argue from theory. It could argue from fact. These were the machines that had helped finish the canal. These were the machines that had survived tropical slides, punishing cycles, and round-the-clock work while the world watched. Every future sales conversation took place in the shadow of that achievement. That is how reputations become industrial assets. They lower customer anxiety. They justify premium pricing. They attract talent. They turn a regional manufacturer into a world reference point. Panama also clarified a deeper truth about Bucyrus that would remain true into the age of Big Muskie. The company's real product was not merely machinery. It was large-scale reliability under harsh conditions. Plenty of firms can build something impressive once. Far fewer can build systems customers trust when delay costs millions, failure destroys schedules, and replacement is not practical. By the time the canal opened in 1914, Bucyrus had crossed that threshold. The company was no longer just an American excavating manufacturer with a strong catalog. It had become one of the names by which the world understood heavy excavation itself. That status would carry it through 2 wars, multiple technological transitions, the rise of strip mining, and the age when size itself became the next battlefield. Factories reveal their real character when the world changes faster than they expected. For Bucyrus, the first great stress test after Panama was war. The First World War shattered the peacetime logic of industry. Plants that had specialized in building one class of machinery were suddenly asked to produce something else entirely. Artillery components, logistics equipment, precision metal parts for military systems that could not tolerate improvisation. Bucyrus had not been founded to build weapons, but it possessed the 2 attributes wartime production valued most: precision and adaptability. It could machine accurately, scale quickly, and reorganize without forgetting what it already knew. During the war years, the company turned significant portions of its capacity toward military output, including shell work, recoil components, railroad equipment, and heavy systems that made modern industrial war possible. The deeper lesson was not what specific parts it built. It was that the factory could reconfigure itself at speed without collapsing into disorder. That ability matters in heavy industry more than people sometimes realize. Large factories are not nimble by default. Their strength is repetition. Their danger is rigidity. Bucyrus repeatedly avoided that trap because its internal culture was built around engineering problem-solving rather than mere line repetition. The workforce understood metal, fit, load, and failure at a level that let management redirect production without starting from zero. When the war ended, Bucyrus did not simply return to normal. It returned with a sharper sense of what the future of excavation required. Steam had carried the company far, but steam also imposed limits. It required constant management, fuel handling, warm-up, and a relationship between operator and power source that was inherently less stable than what electrification promised. At the same time, excavation itself was evolving. New mines, new terrains, and larger surface operations demanded machines that were not just powerful, but mobile and predictable. Several developments in the 1910s and 1920s pushed Bucyrus toward a new era. The first was the dragline. Dragline logic changed the relationship between machine and material. Instead of forcing a bucket forward into the cut, the machine cast it out and dragged it back. That sounds like a technical distinction fit for engineers, but it opened enormous commercial possibilities. Soft ground, waterlogged sites, and stripping operations where push-style excavation became inefficient all suddenly favored a different family of machines. Bucyrus's acquisition of rights and technologies in this space was not just an addition to the catalog. It was a recognition that surface mining was beginning to demand different motion. The second shift was mobility. Tracked crawlers liberated machines from the tyranny of temporary rails. Rail-mounted excavation had been effective, but it also imposed its own slow ritual of movement: lay track, advance, reset, repeat. Crawler systems allowed machines to reposition without rebuilding infrastructure beneath them at every step. In mining, that meant time. In construction, that meant flexibility. In sales, it meant a company could promise something new, not merely power, but maneuverability at scale. The third shift, and perhaps the most consequential, was electricity. Steam did not disappear overnight, but electrical systems offered advantages that became impossible to ignore. Torque arrived differently. Output steadied. Fuel logistics simplified. Operating precision improved. Maintenance regimes changed. What had once been a great steam engineering company began to become something else: a builder of giant electric excavation systems. The Model 120B represented that transition in a way contemporaries understood immediately. It was not just another machine. It was a statement that the future of large digging systems would depend on electrical power and integrated rotating crawler designs. The industry would not look the same after machines like that proved themselves in the field. Then came the Second World War, and the factory was asked once again to become something different under pressure. This time the shift was even more dramatic. With labor pulled into the armed forces, women entered the plant in larger numbers. Production pivoted again toward war support and heavy military-related systems. The point is not to romanticize wartime conversion. It was disruptive, exhausting, and imposed from outside. But it confirmed a pattern that had now defined Bucyrus for decades. When the world changed suddenly, the company did not freeze. It reorganized. After 1945, that mattered enormously. The post-war years were not simply about reconstruction. They were about scale. Demand for minerals, energy, steel, infrastructure, and mass movement of earth expanded with extraordinary force. The machines customers wanted in the late 1940s and 1950s were bigger, more durable, and more specialized than the ones the company had sold before the wars. Bucyrus was ready not because it had predicted every detail, but because the wars had forced it to become a factory capable of changing form without losing identity. This is the crucial distinction. A factory can be flexible because it lacks a center, or it can be flexible because its center is strong enough to survive change. Bucyrus belonged to the second category. It remained, through all those transitions, committed to one basic domain: moving impossible amounts of earth and material with machines that had to work under conditions where excuses were worthless. By the middle decades of the 20th century, the company had accumulated something very few manufacturers ever do. It had a reputation, a workforce culture, and a technical base robust enough to absorb shocks while still pushing into new frontiers. That is what made the next phase possible. Not just bigger machines. An industry strategy big enough to swallow rivals. Most people think of corporate acquisitions as finance stories. For Bucyrus, they were engineering stories disguised as finance. By the time the company entered the post-war era, it was already strong. It knew how to build large excavation equipment, how to manage a major industrial works, and how to sell into infrastructure and mining markets around the world. But strength is not the same as control. To control an industry, you have to reduce the number of things customers can buy somewhere else. Bucyrus did that with remarkable patience. Earlier mergers and combinations had already expanded its reach, but the 1927 union with Erie Steam Shovel Company was the decisive symbolic and operational shift. Erie was not a minor player. It was one of the principal names in excavation equipment, especially in smaller and mid-sized ranges where Bucyrus had not always dominated as completely. When the two combined, the meaning of the business changed. This was no longer a company with pockets of excellence. It was becoming a spectrum supplier, able to meet radically different excavation needs under one identity. The new name, Bucyrus-Erie, reflected that consolidation, but the real importance lay beneath the lettering. Customers who might once have had to choose between specialist niches could increasingly remain within one industrial family. Then came the international dimension. The partnership with Ruston and Hornsby in Britain extended the company's reach into global markets in a way that simple exporting never could. Exporting sends products abroad. Joint ventures embed industrial presence. They create local distribution, support, production logic, and market trust. For a heavy equipment company, that difference is enormous. You are not shipping clocks or clothing. You are selling machines that require service, parts, field credibility, and confidence that the manufacturer will still be there when the machine needs support years later. Bucyrus understood this early. The company's acquisitions in the 20th century also reveal something about how it thought. It did not only buy rivals. It bought missing capabilities. Walking dragline technology was a perfect example. Large machines have a mobility problem. Tracks can bog down. Wheels become absurd. Ground pressure becomes intolerable. Walking systems solved a problem that did not matter at small scale and mattered enormously at giant scale. When Bucyrus brought that technology inside its own world, it was not diversifying. It was eliminating a weakness. The same logic applied to blast hole drills. Before rock is moved, it is broken. Before explosives are placed, holes must be drilled. Owning that capability meant Bucyrus could participate not just in excavation after blasting, but in the earlier stages of the entire mining cycle. The company moved one step closer to system coverage. Hydraulic excavator technologies and smaller machine segments mattered for the same reason. A company that only dominates the uppermost end of scale can still be strategically incomplete. Customers do not always want the largest possible machine. They want the right machine. Bucyrus spent decades pushing toward a position where the answer to more and more excavation and mining problems could be found inside its own product universe. This is one reason the company's later rise to apparent near-total mining coverage did not happen suddenly. It was the result of long accumulation. Capability, then adjacency, then control. By the post-war decades, Bucyrus-Erie was not just a manufacturer that happened to own a few strong product lines. It had become one of the central organizing firms in heavy excavation and surface mining. Whether through direct production, heritage technology, or acquired competencies, it touched more of the workflow than many customers even fully recognized. That status also changed how the company thought about size. Once you stop treating equipment categories as isolated products and start treating them as connected solutions, scale begins to seem less like spectacle and more like inevitability. If the market needs bigger overburden removal, you can build bigger overburden removal. If mobility at that size becomes impossible, you acquire or develop mobility systems. If geology changes the sequence of work, you move upstream or downstream in the process. By the 1950s and early 1960s, Bucyrus-Erie had become one of the few industrial companies on Earth capable of answering heavy excavation questions with something more than a catalog. It could answer with a system architecture. That is what made the age of giant stripping shovels and draglines possible. Not just raw engineering boldness. Institutional breadth. The company had built the capability base required to ask a very dangerous question. If the mine wants something larger than anything that currently exists, why shouldn't we be the ones to build it? By the middle of the 20th century, Bucyrus-Erie was no longer just known for what it built. It was known for the place that built it. Heavy equipment factories are easy to imagine abstractly and difficult to picture accurately. People hear the names of giant machines and tend to imagine empty heroics. Cranes moving impossible components in silence, sparks, giant parts, men in hard hats staring upward at steel. Real factory life is less theatrical and more impressive. It is systems, sequencing, repetition, smell, noise, skill, patience, and the accumulated judgment of people who know when metal is behaving correctly and when it is not. The South Milwaukee Works had become one of those places. By the early and middle decades of the 20th century, the plant operated less like a simple assembly facility than like a contained industrial ecosystem. Foundry work, forging, machining, heat treatment, fabrication, heavy assembly, fitting, field preparation, and shipping all existed as linked domains inside one larger logic. Some workers spent careers in one domain. Others moved between them. Either way, the knowledge environment thickened over time. A pattern maker understood castability. A machinist understood finish and fit. A welder understood sequence and stress relief. An assemblyman understood not just how a part attached, but why it had been made that way in the first place. That density of understanding is one reason so many historic factories become difficult to replace. Their output can sometimes be copied. Their internal human system cannot be conjured on demand. Imagine the place in its productive maturity. Raw steel arriving and disappearing into sequences of transformation. Castings cooling with their own heat still living inside them. Machine tools cutting critical surfaces that would later carry staggering loads. Huge components moving through bays where overhead cranes did not feel like luxuries, but like extensions of the building's nervous system. The smell of foundry sand, hot metal, oil, flux, paint, lake air, and machine heat mixing into that distinct industrial atmosphere workers carry home in their clothes without noticing until their families do. There would have been sounds layered constantly over one another. Hammering, machining, crane motion, shouted signals, forklifts, the grind of preparation, the ring of steel on steel, and the low conversation of people who know each other well enough not to waste words. Great factories are not quiet because so much of their intelligence is acoustic. A good machinist hears chatter before he sees damage. A good fitter hears misalignment in the way weight settles. A veteran worker can tell the difference between strain and normal operation by the sound a component makes when a crane takes it up. This is what outsiders often miss about industrial labor. The work is physical, yes. It is also interpretive. Bucyrus-Erie's South Milwaukee workforce carried that interpretation across generations. The city's own historical material says plainly that many families sent workers into the plant across third and even fourth generations. That kind of continuity does not merely stabilize staffing. It shapes identity. A young worker enters not as a blank slate, but as somebody who has grown up hearing stories about the plant, who may already know the names of departments, foremen, buildings, and machine families before the first day on the payroll. That is why company towns and anchor factory cities carry such deep memory. They do not just host jobs. They host inherited belonging. The company reinforced this for decades. Homes were sold to workers at cost. The Bucyrus Club offered recreation and civic life. Downtown patterns adjusted around shift schedules and wages. The plant did what all large industrial centers do when they are healthy for long enough. It turned the town around itself into a support structure, and in turn drew strength from that support structure. There is also a moral complexity here worth acknowledging. Factories that dominate towns produce belonging and dependency together. The same arrangement that builds pride can trap communities when the center fails. A generation raised to think of one plant as the natural destination of adult life can find itself unmoored when that plant no longer exists. Bucyrus gave South Milwaukee stability. It also made South Milwaukee structurally vulnerable to what would later happen. But that vulnerability is part of the story because it is part of what made the place so formidable when it was alive. At the height of the works, the plant did not feel like a branch office. It felt like the thing the town existed to support, and the thing that justified the town's sense of itself. Men and women there were not making generic goods. They were building machines that went to Kansas, Ohio, Panama, Minnesota, Canada, Australia, South Africa, and anywhere else immense quantities of earth had to be moved. World geography passed through South Milwaukee in reverse, as orders, field reports, service needs, and engineering adaptations. A factory like that teaches its workers something rare, that the object under your hands is going somewhere hard. That knowledge changes how people work. A cabinet in a furniture plant matters. A gearbox housing on a giant shovel matters differently when you understand that it may spend decades in an environment where failure costs fortunes and help is days away. Bucyrus machines earned their reputation partly because the factory culture understood that field seriousness. These were not products designed for ideal conditions. They were built for hostile ground and punishing duty cycles. The effect on South Milwaukee lasted well beyond the payroll. It shaped self-respect. It shaped what the city imagined industry was. It shaped what counted as real work. It shaped what older generations told younger ones about competence, toughness, and staying power. Which is why when the plant finally fell silent, the loss was not just the absence of production noise. It was the sudden interruption of a social world in which that noise had meant continuity. There is a point in any mature industry when technical improvement stops looking incremental and starts looking mythic. For Bucyrus-Erie, that point arrived in the 1960s. The company had already spent decades building larger machines, but the machines of this era crossed a psychological threshold. They no longer felt like enlarged tools. They felt like industrial landforms, structures so big that language itself struggled to hold them properly. A bucket was no longer a bucket. It was a room. A boom was no longer a boom. It was a horizontal tower. A shovel was no longer a piece of equipment. It was an environment. The 3850 B was part of that transition. So was the 1850 B, later known as Big Brutus. So were the Silver Spade and the GEM of Egypt. Each of them matters for its own reasons. Together they reveal what the company had become. Take Big Brutus first. Delivered to Kansas in the early 1960s, Big Brutus was not the largest machine the company ever built, but it occupies a special place in the public imagination because it survived. It had to be dismantled in South Milwaukee, shipped in huge sections by rail, and reassembled on site, an operation that itself demonstrated the strange physics of this industry. These machines were so large that transport became its own project. Once erected, they tended to stay where they were. You did not casually relocate a machine like Big Brutus. You either found new work for it in the same territory or you left it where it stood. That permanence did something to people who saw these machines in service. They ceased to feel temporary. They seemed instead, like civic facts, as fixed in the landscape as grain elevators or church steeples. Then there was the Silver Spade and its twin, the GEM of Egypt. These machines pushed output and mass to a point where world records began to blur together. In another era, each would have defined the outer limit of practicality. In the Bucyrus-Erie world of the 1960s, they were part of a continuing escalation. This is the key to understanding the company at its peak. Gigantism was not a publicity stunt. It was a response to economic logic in strip mining and overburden removal. If a machine can move more material per cycle and operate economically over vast mine lives, then size becomes rational, until the surrounding economics fail. But before they failed, the logic looked irresistible. Mining companies wanted enormous overburden stripped faster and cheaper over decades. Power demand was rising. Coal seemed secure. Scale appeared to answer everything. Bucyrus-Erie was the company best positioned to translate that demand into steel. By this point, the South Milwaukee works had become a place where extraordinary things could be normalized. That is one of the hidden features of great factories. They change what feels ordinary to the people inside them. Somewhere else a machine the size of Big Brutus would be treated as a once-in-a-generation impossibility. In South Milwaukee it became another job, difficult, prestigious, technically intense, but still a job. Drawings had to be finalized. Components had to be fabricated. Shipping had to be coordinated. Assemblies had to fit. Field erection had to succeed. Myth outside, workflow inside. And then the requests got larger still. This is where Big Muskie enters, but it is important to see that Big Muskie did not emerge from nowhere. It emerged from a decade in which Bucyrus-Erie had already taught itself, and its customers, that enormous size was not only possible but commercially meaningful. The company had been building toward a machine like Big Muskie long before the Ohio contract made it real. The public tends to remember these giant machines as isolated marvels. The truth is less romantic and more impressive. They were the visible tips of a much deeper industrial system: metallurgical judgment, fabrication scale, field erection logistics, electrical engineering, structural design, customer trust, and a workforce accustomed to translating absurd specifications into working equipment. That last point matters. Industrial gigantism is often narrated as executive bravado or engineering ego. In reality, it is also a labor story. Somebody had to lay out the steel, cut it, fit it, weld it, machine the critical surfaces, manage distortion, keep tolerances where they mattered, and then help erect the whole thing in the field. Somebody had to solve the 1,000 unglamorous problems that stand between a contract drawing and a working machine. The people in South Milwaukee did that again and again. This is why the plant mattered so much to the town. It did not merely employ workers. It employed workers in a system capable of world-historic difficulty. When those workers built a giant stripping shovel or a massive electric machine, they were not just earning a wage. They were participating in a level of industrial capability very few places on Earth possessed. That is what the Age of Giants really represented. Not just bigger buckets. A factory culture capable of making the improbable routine. Big Muskie was the moment when that factory culture reached its most audacious expression. The common headline version is easy to remember. Largest dragline ever built. 220 cubic yard bucket, roughly 13,500 short tons, around 22 stories high, operating in Ohio from 1969 to 1991, later dismantled in 1999, with only the bucket preserved. All of that is true. None of it fully captures what Big Muskie meant. To understand Big Muskie, you have to understand the problem it was built to solve. The mine in Ohio was vast, hilly, and economically defined by overburden. Large volumes of earth had to be stripped to expose the coal below, and the existing fleet options were not optimal for the terrain and scale involved. The mine's owners did not ask for a piece of spectacle. They asked for a machine that could move extraordinary quantities of earth more profitably than the available alternatives. Bucyrus-Erie answered in the only way a company like that could answer by the late 1960s. It designed a machine so large that the ordinary vocabulary of mobility stopped working. Big Muskie did not roll into place like a truck. It did not travel like a crane. It was built for a single operating environment and moved by walking. Two massive shoes lifted, shifted, and set the machine down again over and over. Every step looked slow enough to seem almost ceremonial, but the slowness was deceptive. This was not graceful motion. It was weight redistribution on a scale almost beyond intuition. The dimensions still sound unreal because they were. A boom over 300 feet long. A bucket capable of holding 220 cubic yards. A total mass that approached twice the weight of the Eiffel Tower's iron structure. A machine length stretching hundreds of feet. An electrical appetite so immense that Big Muskie operated less like a vehicle than like a mobile industrial district connected to the grid. And yet, for all that scale, the essential act was simple. Cast the bucket. Drag it through the earth. Lift. Swing. Dump. Repeat. That repetition is worth dwelling on because it is the thing giant machines always reduce to. No matter how extraordinary the size, the work becomes a rhythm. Operators learn the cycle. Crews learn the maintenance. Managers learn the productive pace. A machine that seems impossible from a distance becomes, for the people living with it, a demanding routine. Big Muskie entered service in 1969 and worked for 22 years. In 1976, according to Caterpillar's later historical account, it was removing roughly 8,000 yards of overburden per operating hour. Over its service life, it moved a quantity of material so vast that comparisons to the Panama Canal stopped being rhetorical flourish and started looking numerically useful. Big Muskie did not set records accidentally. It embodied a whole industrial philosophy that when confronted with a large enough excavation problem, the rational answer might simply be to build a machine larger than anyone has ever built. No one has since. That is part of what gives Big Muskie its strange afterlife. It was not merely the biggest of its time. It appears, at least so far, to have belonged to the end of an era in which such size still looked like the future rather than a dead end. Later mining innovation would pursue efficiency, flexibility, systems integration, and different equipment mixes. The idea that the path forward necessarily meant bigger and bigger single-bucket earthmovers did not survive intact. Big Muskie therefore stands as both culmination and warning. Culmination because it represented the outer edge of what Bucyrus-Erie and its industrial ecosystem could do. Warning because it tied success to a set of assumptions about energy, mining, land use, and capital expenditure that would eventually prove unstable. Even its end tells that story. Big Muskie did not die because it mechanically failed in some cinematic collapse. It shut down in 1991 because the economics no longer justified keeping it alive. When it was finally dismantled in 1999, the reason was not physical impossibility alone but rational cost. There was no profitable world in which preserving the whole machine made sense. So the steel went to scrap and the bucket survived as relic. That survival matters. People can stand inside the bucket today and experience, at least briefly, the scale of the vanished whole. But the bucket is also a lesson in industrial memory. Great systems often leave behind only fragments. A photograph. A casting plate. A preserved cab. A bucket in a park. The working totality disappears first because it is too large, too expensive, too entangled with dead economics to remain intact. Big Muskie's afterlife therefore mirrors Bucyrus-Erie's own. The full machine is gone. The proof that it existed remains. And the fact that nobody has surpassed it tells you something uncomfortable and magnificent at the same time. South Milwaukee built the largest walking dragline the world has ever seen, and the world has not decided to do it again. That is not just a record. It is evidence of where an entire industrial civilization once believed its future was heading. It is easy to turn Big Muskie into folklore. It is harder and more worthwhile to remember that it had to be engineered, fabricated, shipped, assembled, maintained, and justified by ordinary people inside a very extraordinary system. The order that produced Big Muskie was not for a legend. It was for a working machine. Central Ohio coal needed a dragline capable of handling enormous volumes of overburden on terrain that made a walking machine more profitable than conventional alternatives. Bucyrus-Erie responded with the Model 4250W, the only one of its kind ever built. That "only one" is an important phrase. Most great industrial products become lines. They spawn descendants, variants, and production families. Big Muskie instead represented a singular concentration of a company's accumulated knowledge. Not a prototype in the experimental sense, but a one-off at world scale. Every part of Bucyrus-Erie's institutional memory had to come to the surface at once. Structural design, load paths, walking systems, dragline geometry, electrical power distribution, fabrication sequencing, erection strategy, field service logic. It was a company building not just a machine, but its own capability made visible. Construction began in the late 1960s. The machine had to be built in major sections and assembled on site because complete transport was impossible. Even saying "assembled on site" understates the operation. Big Muskie was not erected like a building from a standard kit. It required a choreography of giant components, specialized lifting, crews who understood both the plan and the necessary deviations from the plan, and a managerial confidence that problems encountered in the field could be solved without turning into disaster. Machines of this scale punish small mistakes brutally. A tolerance issue that might be annoying in ordinary equipment becomes existential when components weigh tons and must fit in sequences that later cannot easily be reversed. An alignment problem can ripple through the whole structure. A field erection crew therefore has to do more than follow drawings. It has to think. This is where the South Milwaukee culture mattered. Big Muskie was built by a company accustomed to translating vast specifications into working steel. The people involved were not improvising from scratch. They were operating at the edge of a discipline they already understood well. Once complete, the machine's scale became difficult even for experienced observers to process. The bucket alone weighed hundreds of tons. The walking shoes spread enormous load across the ground. The boom reached farther than most people can intuit without standing beneath it. The whole dragline drew immense electrical power through trailing cable rather than carrying its own fuel logic in the traditional mobile sense. It was less a vehicle than a movable industrial installation. And yet the work cycle remained brutally simple. Cast, drag, lift, swing, dump, repeat. That repetition, hour after hour and year after year, is what converted engineering bravado into economic reality. Big Muskie's purpose was not to impress. Its purpose was to make money by moving overburden at a scale and cost profile that justified its existence. The machine did that for more than 2 decades. It became a functioning part of an energy system, not a temporary stunt. Operators and crews who lived with the machine learned its rhythms the way marine crews learn a ship. Giant equipment of this kind ceases to feel abstract for the people inside it. They know the way it settles. They know what sounds normal and what does not. They know what maintenance intervals matter. They know how weather changes footing, how production shifts with ground conditions, how management optimism compares to real field pace. It becomes not an icon, but a demanding companion. This is another reason giant machines matter historically. They create communities of expertise around themselves. Big Muskie was not just steel. It was electricians, operators, maintenance workers, planners, lubrication routines, inspection habits, replacement cycles, and hard-won field knowledge that existed because the machine existed. By the late 20th century, however, the world that had justified such machines was changing. Environmental pressure increased. Coal economics grew more complex. Capital allocation changed. When Big Muskie shut down in 1991, it was not because the machine had become unthinkable in engineering terms. It had become harder to justify in financial terms. Those are not the same thing, and industrial history is full of systems that die for the second reason while remaining physically capable of continuing. Dismantling it in 1999 was therefore an act of accounting as much as demolition. Keeping the machine intact offered little economic return. Scrapping it released value. Only the bucket remained to stand as a monument and an educational object. There is something bleakly modern in that ending. The world's largest dragline, built through extraordinary concentrations of labor and engineering, reduced to commodity value plus one symbolic fragment. And yet that symbolism matters precisely because the totality is gone. The preserved bucket makes it possible to grasp a truth the full machine once made impossible to ignore. There was a time when an American factory town could build something this vast, this specialized, and this singular because a whole industrial culture existed to make such things normal. Big Muskie is remembered as a monster machine. It should also be remembered as a proof of what South Milwaukee knew how to do. If Big Muskie was the physical peak, the 1970s were the financial peak that set up everything which followed. The sequence looked rational while it was happening. That is what makes industrial overexpansion so dangerous. It does not usually feel reckless in real time. It feels responsive. The 1973 oil shock changed the energy conversation almost overnight. Imported oil suddenly looked strategically dangerous. Coal, by contrast, looked domestic, abundant, and already wired into American power generation. Utilities moved to secure long-term supply. Mining companies expanded expectations. Capital surged into coal. And when the world decides it urgently needs more coal, the companies that build giant stripping shovels, draglines, and drills begin to look indispensable. Bucyrus-Erie was one of the clearest beneficiaries of that shift. Orders surged. Backlogs lengthened. Management faced the kind of problem executives tell themselves they would love to have: more work in the queue than present capacity could handle in any reasonable time frame. By the mid-1970s, the backlog reportedly reached levels that implied years and years of future production already spoken for. Looked at from the boardroom, the conclusion almost wrote itself: build for the future that is visible in front of you. So Bucyrus-Erie expanded aggressively. Plant area increased. Capacity was added. Infrastructure was built to support projected volumes. The company behaved like a firm that believed the new demand environment would persist long enough to repay the capital it was locking into place. And for a while, the evidence seemed to support that belief. Revenues climbed. Production remained strong. The expansion looked not like speculation, but like industrial discipline. This is where commodity industries punish confidence. Because the danger in cyclical booms is not that companies fail to recognize the boom. It is that they internalize it. They begin to treat temporary conditions as structural ones. They convert demand spikes into fixed obligations: buildings, equipment, payroll structures, debt, maintenance burdens, and all the overhead that remains when the orders thin out. That is what Bucyrus-Erie did. The company had built its strength for decades around technological depth and strategic patience. In the 1970s, it made a decision that substituted macroeconomic optimism for those older habits. It scaled not only production but exposure. Then the environment changed. Coal did not disappear, but the certainty around it began to erode. Oil prices moved differently. Regulatory burdens increased. Environmental politics hardened. New generating assumptions came under pressure. Mining companies became more cautious with capital. The great build-out logic of the mid-1970s no longer looked inevitable. And unlike variable costs, fixed industrial costs do not politely step aside when demand softens. Buildings still require maintenance. Skilled workers still require wages. Machine tools still depreciate. Utilities still arrive. Debt service still exists. A capacity structure created to serve a peak becomes a burden when that peak recedes. Bucyrus-Erie had built itself for a world that did not fully arrive on the timetable it expected. The consequences were painful and slow. Facilities were sold, shuttered, or consolidated. Product focus narrowed. The company retreated toward core competencies because it had to. None of this meant the engineering had failed. The machines still worked. The customers who needed them still respected them. The institution's problem was now structural rather than technical. This distinction is crucial. Industrial decline is often narrated as though a company forgets how to build. Much more often, it remembers perfectly well and still gets crushed by the mismatch between its cost base and the market that now exists. Bucyrus-Erie entered that zone in the 1980s. The giant machines that had once made it look invincible now tied it more tightly to customers in industries whose own economics were under pressure. Surface mining remained important, but it was no longer the unquestioned growth frontier it had appeared to be in the years immediately after the oil crisis. The company had concentrated enormous resources around a future that had become uncertain. What follows from that is one of the hardest truths in industrial capitalism. A company can dominate its field, lead technologically, employ a loyal and skilled workforce, produce world-famous machines, and still be made fragile by timing. Not because the products are inferior, because the cost structure was designed for a stronger market than the one that actually arrived. By the early 1990s, that fragility could no longer be hidden behind reputation. In February 1994, Bucyrus-Erie filed for Chapter 11 protection. There is a temptation to read a bankruptcy filing as the end of the story. For weak companies, it often is. For companies with genuine engineering strength and strong customer relationships, bankruptcy can instead function like a brutal diagnosis. Proof that the business model as structured has failed, but also proof that creditors still think something inside it is worth saving. That was the case here. Bucyrus-Erie had not forgotten how to build giant machines. It had built itself too expensively for the world it was now selling them into. The company survived by cutting away sentiment. When Bucyrus emerged from bankruptcy in December 1994, it did so fast by the standards of major industrial restructurings. That speed mattered. Long bankruptcies corrode trust. Customers hesitate to place long-horizon orders with a manufacturer that may not look the same by the time delivery arrives. Suppliers tighten terms. Talent drifts. Competitors exploit uncertainty. Bucyrus did not permit that uncertainty to linger for long. The restructured company that emerged was narrower, harder, and more focused. Product lines were rationalized. Non-core assets were gone. The identity that survived was the one that had always mattered most. Giant surface mining systems, drills, and the highest-end excavation technologies that relatively few manufacturers in the world could match. This is an old industrial pattern and an unsentimental one. In boom years, companies tell themselves they are diversified. In crisis years, they discover what customers actually cannot replace. For Bucyrus, that answer lay at the top of the scale curve. Then the company did something that separated it from firms merely trying to survive. It went back on offense. In 1997, it changed its name to Bucyrus International, a subtle admission that the old regional logic no longer described the business accurately. The word Erie disappeared from the corporate title, which was symbolically significant and emotionally costly if you cared about industrial heritage. But the name change also announced a strategic ambition. This was no longer a legacy maker nursing old glories. It meant to act like a global consolidator. And almost immediately, it proved it by acquiring Marion Power Shovel. That was a remarkable move. Marion was not some peripheral asset. It was a historic competitor, another American giant in the world of enormous mining machinery, builder of its own titanic equipment, and a company with deep engineering prestige. Buying Marion did more than increase market share. It absorbed a rival tradition. It brought in designs, relationships, expertise, and one of the last major names capable of contesting the upper end of the field. This acquisition changed the competitive landscape profoundly. After Bucyrus absorbed Marion, the number of Western companies able to build the largest mining machines on Earth shrank even further. The industry was no longer crowded. It was concentrating around a handful of giants, and Bucyrus intended to be one of them. The same pattern continued in the 2000s. In 2007, Bucyrus acquired DBT, adding major underground mining capability and moving below the surface in a strategic sense. Until then, the company's greatest prestige had come from vast visible machines, shovels, draglines, drills, and surface systems. DBT brought long-wall equipment, armored conveyors, roof supports, and the machinery of underground extraction. This was not adjacent for the sake of adjacency. It was vertical integration across the mining process. Then came the 2010 Terex mining acquisition, which brought another major set of product lines into the fold, including large hydraulic mining equipment. That move significantly expanded Bucyrus's range and pushed the company closer to full-spectrum mining system status. Surface, underground, hydraulic, rope shovel, dragline, drill. A customer could increasingly imagine one supplier covering far more of the total problem. By then, the company that had gone bankrupt in 1994 had become something unexpectedly formidable. This kind of resurgence tells you something important about what bankruptcy had actually revealed. It had not revealed technical decline. It had revealed a bad structure around good capabilities. Once that structure was reset, the company's engineering seriousness and industry reputation reasserted themselves with surprising speed. But resurgence of that kind creates its own risk. When a company becomes too strategically complete in a high-capital field, it stops looking merely like a competitor and starts looking like a missing division for somebody larger. That is the paradox of successful industrial recovery. The better you rebuild, the more attractive you become to an acquirer who can integrate your strengths into an even bigger machine. By 2010, Bucyrus had positioned itself exactly there. It had reclaimed credibility. It had expanded its product scope. It had consolidated rivals. And it had become, once again, too important to ignore. When Caterpillar moved on Bucyrus in 2010, the logic was easy to understand. Caterpillar was already one of the defining names in construction and earth-moving equipment. But mining at the very top end, especially the extreme capital equipment side, was a different world with different customer relationships, machine types, service expectations, and engineering traditions. Buying Bucyrus was faster than building that capability from scratch. Much faster. The acquisition, valued at roughly $8.8 billion including net debt when it closed in 2011, erased Bucyrus as an independent company. That sentence needs to be read slowly because it is the sentence industrial history keeps repeating. A company can survive depressions, wars, market cycles, technological revolutions, and bankruptcy, and still disappear because another company can use its capabilities more efficiently under a larger corporate roof. Caterpillar did not acquire ruins. It acquired relevance. The products were rebranded. The name Bucyrus, after more than 130 years of industrial life and more than a century in South Milwaukee, was consigned to history as a living corporate identity. That is one kind of death. The other kind came later and was harder for the town. For a while the South Milwaukee site continued under Caterpillar ownership. Work still happened. Some continuity remained. And continuity, even partial continuity, can deceive communities into thinking the center may yet hold. But the conditions that had defined the early 21st century mining business were changing again. Commodity prices softened, global competition intensified, and large manufacturers kept reassessing where production should sit inside their broader footprints. In 2016, Caterpillar announced the closure of production at the main South Milwaukee plant. No grand final act. No national reckoning. Just the kind of corporate decision that arrives in a town after being solved elsewhere, in financial language that sounds neutral until it reaches the people who must live inside it. Production at the main plant ceased after 123 years of continuous operation. A factory that had helped build South Milwaukee, housed multiple generations of industrial skill, and anchored the civic identity of the city finally went quiet. The city's own historical material says plainly what that meant. Many South Milwaukee residents either worked there themselves or had relatives who did, sometimes into the third and fourth generations. That is not the language of an employer. It is the language of lineage. This is what makes the end of such factories different from the closure of a warehouse or the relocation of a call center. When a place like Bucyrus falls silent, the loss is not only economic. It is temporal. A chain of knowledge transmission gets broken. An inherited assumption about what kind of work a town does becomes unstable. Younger people no longer grow up with the same certainty that the great building at the center of town has a place for them if they prove worthy of it. In South Milwaukee, the property did not remain frozen in grief forever. Redevelopment began. Ownership changed hands. Parts of the site entered new lives. But redevelopment is not replacement in any simple moral sense. A redeveloped industrial site may produce taxes, jobs, even energy, but it rarely reproduces the exact social and civic role played by the old anchor factory. That is why industrial communities so often sound unresolved years after closure, even when the unemployment rate improves. Statistics can recover faster than identity. There is a certain final cruelty in the Bucyrus story. The company that had built machines capable of stripping mountains, finishing the canal, and redefining mining scale was not brought down by engineering inferiority. It did not lose because its workers forgot their craft. It lost because industrial capitalism keeps rewarding concentration until the concentrated thing becomes worth more as an acquired component than as a self-governing whole. The name vanished first. The factory followed. But the engineering did not completely disappear. It was absorbed into other products, other brands, other corporate systems. That is how legacy often survives in modern industry, not as sovereignty, but as DNA inside something else. For towns, that is rarely much comfort. South Milwaukee did not spend more than a century orienting itself around a set of transferable technical competencies in the abstract. It oriented itself around Bucyrus, around the specific fact that these machines, these world-scale machines, came out of this place. When the factory fell silent in 2016, what ended was not merely a production run. It was a sentence the town had been saying about itself since 1893. The easiest way to misread Bucyrus-Erie is to treat it as a machine company and stop there. It was a machine company. It also built something much larger and much harder to preserve. It built a system of belief. The belief began with specialization. Early in its life, the company made the crucial decision to stop being merely competent across many things and become deep in a few. That choice created expertise dense enough to matter. Over decades, that expertise compounded into reputation. Reputation created trust. Trust created contracts large enough to justify still deeper expertise. This is what industrial dominance often looks like from inside. Not one genius leap, but a long sequence of disciplined narrowing that makes you indispensable. Then it built a place where that indispensability could be embodied. South Milwaukee was not an accident of geography after 1891. It became a manufacturing ecology. Housing, utilities, clubs, schools, family life, and intergenerational labor all aligned around one industrial center. The company did not simply rent labor there. It helped organize a town around the work and then benefited from the stability and skill accumulation that town produced in return. That reciprocal arrangement has become harder to imagine in an era of floating capital and flexible sourcing, which is partly why stories like this feel almost mythic now. We are not used to factories functioning as civic institutions. We are used to them functioning as assets. Bucyrus also built a certain relationship to scale. The company's history keeps moving from one large challenge to the next. Railroads, dredging, Panama, war production, draglines, strip mining, giant power shovels, Big Brutus, Big Muskie, global mining integration. At every stage, the internal question seems to have been some variation of the same thing. What does the problem require if we ignore what smaller imaginations would call reasonable? That habit can be dangerous. It can produce Big Muskie and also the expansion trap of the 1970s. It can create dominance and also create the kind of strategic completeness that invites acquisition by a larger predator. Scale is not morally good. It is simply a force multiplier. It multiplies good judgment. It also multiplies misjudgment. This is one reason the Bucyrus story matters beyond nostalgia. It is not a sentimental fairy tale in which everything was better when factories were bigger. Big factories can overreach. They can pollute. They can tie communities too tightly to one employer. They can become vulnerable precisely because they are capital heavy and cycle exposed. Bucyrus did all of this. The giant machines it built were marvels and instruments of an energy regime whose environmental consequences are impossible to ignore. And yet there is something worth preserving in the story beyond its romance. It is the seriousness. Bucyrus represents a culture in which making hard things well for difficult customers over long periods of time could still form the center of a city's identity. A culture in which problems were solved with metal, electricity, fabrication, logistics, and patience. A culture in which greatness could emerge from a factory town rather than from an abstract brand deck. A culture in which skill accumulated locally and visibly. When people visit the Bucyrus Museum today, or stand inside the Big Muskie bucket in Ohio, or look up at Big Brutus in Kansas, what they are confronting is not just industrial scale. They are confronting evidence that a different kind of American ambition once existed. Less frictionless, less virtual, less interested in appearing smart than in proving it by what could be built, shipped, erected, and made to work in the field. The machines are relics now, but the lesson is not. A nation still needs the capacity to make difficult physical things. It still needs places where intergenerational skill can accumulate. It still needs organizations willing to choose depth over distraction and serious engineering over performative innovation. What Bucyrus shows is both how powerful that capacity can become and how vulnerable it is once ownership, scale, and strategic logic detach from the place that generated it. That is why the silence in South Milwaukee in 2016 felt like more than a closure. It felt like a verdict on a whole way of organizing industrial life. The bucket survives. That is how many industrial epics end. Not with the whole thing preserved, but with one fragment too large, too strange, too historically charged to melt down and forget. Big Muskie's bucket sits in Ohio like a steel chapel to an extinct faith. Big Brutus still stands in Kansas because moving it made less sense than leaving it where it had worked. The Bucyrus Museum keeps nearly 20,000 artifacts, drawings, documents, and memories alive inside the old Bucyrus Club in South Milwaukee. The town still carries the company in its vocabulary, whether the signs over the gates do or not. And somewhere in mines far from Wisconsin, machines with different logos still carry Bucyrus DNA forward. Electric rope shovels still bite into the earth. Draglines still walk. Drill systems still prepare the blast. The independent company is gone, but the engineering bloodline lives on inside other names. That is what makes this story larger than loss. Bucyrus-Erie was never just a catalog of giant machines. It was an argument made in steel over 130 years. An argument that specialization, geographic intelligence, accumulated skill, and industrial seriousness could build not just a successful firm but an entire civic world. That world did not survive intact. Very few do. It was absorbed, restructured, renamed, and finally silenced in the place that had sustained it longest. But for more than a century, on the edge of Lake Michigan, a factory proved that world-scale engineering did not have to come from the obvious places. It could come from a town of workers and immigrants and machinists and pattern readers. It could come from an abandoned foundry bought for $17,000. It could come from people who knew how to solve physical problems without asking first whether the solution would look reasonable from a distance. That is why the story still matters. Because somewhere between Panama and Big Muskie, between the first rotating steam shovel and the final silent shift in 2016, Bucyrus-Erie built one of the great industrial legacies in American history. And if you want to know what American manufacturing was at its most ambitious, most disciplined, and most dangerous, you could do worse than start there. In South Milwaukee, where the biggest machines on Earth were once just another day's work. If you want more long-form stories about the factories, brands, and machines that built the modern world, subscribe to Rust and Glory.